This is an example of an exponential equation. We are solving for x. In this case, we can either write the bases as the same or we can't. If we can write the bases as the same, we can solve without logarithms. If we cannot rewrite each of these so that the bases are the same, we'll use logarithms to solve. Now notice I can write 1 over 64 as 8 raised to some power, so in this case we can make the bases the same. I'll leave this left side alone. That's 8 raised to a power of x minus 1 is equal to, now 1 over 64 is 64 to what power? It's 64 to the negative 1 power. And then let's continue. I'm just rewriting the left side. 64 itself, 64 is 8 squared, so the square would be multiplied by negative 1, and this is 8 to the negative 2 power. Now you could have done this right side in probably one of two orders. You could have written first 64 as 8 squared, then moved it up to the numerator as 8 to the negative 2. That's fine, or in the order that I just did. But 8 to the negative 2 power is 1 over 64. Now that the bases are the same, what happens is the following. If 8 raised to a power of x minus 1 is going to equal 8 raised to a power of negative 2, that will only happen if these exponents equal each other. So notice now I'm setting the exponent on the left side equal to the exponent on the right side. We now solve this for x. And how do we solve for x? We add 1 to both sides, and I'll have x is negative 1. Now I'll let you check. I'm saying negative 1 is the exact solution here. You check exponential equations just like every other equation. You check by replacing your proposed solution for x in the original equation. Notice if x is negative 1 minus 1 is negative 2, and you have 8 to the negative 2 is 1 over 64, a true statement.